Hello, Philip Cox here once again. This is my 5-minute video for the BuckyBot megastructure entry for the Hackaday Prize. I'm going to assume that you've all seen my previous 2-minute video that explains what BuckyBots are all about. Saving Earth, board cubes, etc. You should remember that BuckyBots just make a simple geometric shape, but builds them using fractal principles in order to create megastructures. So now that you know what they're intended to do, I'll provide the bot design details. And first, here's a block diagram of the system. There are two somewhat independent subassemblies. First, there's the crawler or spider, and second, there's an extruder that melts and deposits plastic. Ultimately, we'd like to build with stainless steel, but we'll settle for ABS to start. The spider provides locomotion from place to place over the build. A build is just that portion of the megastructure that's been built previously. It has an Arduino Mega as its controller, soldered to a shield board of my own design. The spider is based on Vlad's Hexabot, a design I grabbed off the net at GrabCAD. I've modified it to make it a bit stouter and added thrust bearings to the rotation axis of each leg. This extruder is of my own design. It attempts to address several problems seen in the regular rep-wrap type glue gun extruder. It has a vacuum jacket to save power, and it has an internal screw to provide positive, more controllable feed to the filament. Heat is provided by a Kapton foil heater, not a cartridge heater. The extruder assembly is mounted in a nice little motion table of my design. I'm quite proud of it. That allows rotation of the nozzle in pitch and roll and translation of the nozzle up and down. The entire subassembly has 3 degrees of freedom. When combined with the motion range of the spider, the nozzle has lateral X and Y motion as well, making 5 degrees of freedom for the extrusion nozzle. That permits the BuckyBot to build in any plane, not just the single plane of a tabletop 3D printer. Okay, let's talk about the electronics in more detail. That mega shield board has GPS, magnetic compass, barometer, 3-axis accelerometers, and an FM FSK modem, all on the I2C bus. It handles the servos for locomotion, communicates with central PC, and communicates with the extruder. All 18 leg servos are controlled by an LED controller, capable of putting out 24 concurrent PWM streams. All the Arduino does is write to that chip's registers over the I2C bus to set each servo PWM duty cycle. The Arduino does not have to produce any native PWM signals on its own. Consequently, all those servos appear to move simultaneously, not serially. We intend to eventually do an Inmarsat hack to get the free Starfire data that will allow the shield board to do differential GPS and report its position to the central PC down to about 10 centimeters. And by the way, that central PC is meant to track and coordinate movement between multiple BuckyBots over their FM links. It's connected, allowing web access for everybody to check on build progress, and maybe even allowing the public to influence the build in real time. And that might be an invitation to disaster, but it could be done. Can you imagine replacing Buckminster Fuller's Manhattan Dome with a mile-high bust, say, of Stephen Colbert? Okay, the extruder is controlled by its own Arduino Nano, again with its own shield board of my design. It communicates with the Mega on the spider over the I2C bus. This board has its own 3-axis accelerometers to provide feedback to the Mega about the pitch and roll of the extruder. It controls the nozzle heat by PWM, reads the nozzle temperature by measuring the thermistor, and controls the extruder's screw speed and hence the extrusion rate by another PWM output. The vertical translator has an optical encoder that provides position feedback. And finally, the Nano runs the continuous servo that powers the threaded rod that, in turn, raises and lowers the extruder. And last, all electronic and mechanical design documents are available and deposited at the BuckyBot pages www.renarchy.org.